Let's talk about static volume under durable volume type. So in static, we have to create PV and PVC. PV stands for persistent volume and PVC, persistent volume. So what is static volume? We have three different storage server: SAN 400 TB SSD, SAN 400 TB HDD, and NFS 100 gig. We have one Kubernetes cluster. This is our deployment, and this deployment create this pod. We want to mount these storage servers on this port so that our application which is running inside this pod can save some files. In simple word, we want a persistent volume that will remain available after this container or pod dies. But these storages are outside of the cluster. In order to solve this issue, Kubernetes came up with one solution, and they offered a new binary, that binary called persistent volume. Short form is PV. PV is implemented as a plugin in the Kubernetes. We create three different PVs and point to the particular storage. Now we have the link between the external storage and PV, but still there is no link between pod and PV. Therefore, Kubernetes again offered us a new binary or object, that is PVC, called PersistentVolumeClaim. Now PVC has the communication between PV and pod. It means that in the PVC YAML file we have to mention which PV I need to connect. So we have to create persistent volume claim, and this persistent volume claim will be bind with one pod. If we want to access the other volume, then we have to create a new PVC like this, and like this. So one PVC is dedicated for one PV. In short, in static, if we want to use volume in pod, we have to create two more objects called PV and PVC. Please note that PV is dedicated to one PVC. It is not a shared object. So what we understand that persistent volume is not the namespace. It means that persistent volume will be available to the entire cluster. This is my Kubernetes cluster, and inside this Kubernetes cluster I have one namespace called namespace 1, and the second is namespace 2. We can create the pod and also create the PVC inside the namespace, and we can link it like this. However, when we create a PV, we never use namespace. So this PVC is connect to this PV. In the second namespace, when we create a pod, we have to create a PVC inside that namespace only. But we can link this PVC to external PV that is created outside the namespace. So what we understand that persistent volume is not the namespaced object. It means that persistent volume will be available to entire cluster. However, PVC is namespaced. It can be created under the namespace. Thus, pod which request PVC, both must be on the same namespace. This is the simple persistent volume YAML file. Let's explore all the values. The very first one is kind equal to persistent volume, and the name of this persistent volume is NFS PV. We can define any name. And under spec section we have access mode, read, write, many. There are other four types are there. Let's explore it. Read, write once. In numeric we can say RWO. Read, write once. In this mode, volume can be mounted as read, write by a single node. It can allow multiple pods to access the volume when the pods are running on the same node. In read only many mode, in this mode, volume can be mounted as a read only by many nodes. Please bear in mind, in the read-write ones, this volume can be accessed inside one node only, means worker node 1 or worker node 2, only one node. However, in the read-only many, we can share this volume to the entire cluster. The third one is read-write many. The volume can be mounted as read-write by many nodes. So what's the difference between read-only and read-write? Volume can be mounted as read-only by many nodes, but here read-write by many nodes. And the last one is read-write once pod and numeric as RWOP. So X is for many. Please keep in mind here. Volume can be mounted as read-write by a single pod. Use read-write once pod access mode if you want to ensure that only one pod across whole cluster can read that PVC or write to it. Only single pod. This is only supported for CSI volume and Kubernetes version 1.22 plus. So this is a new option. So let's move further. Persistent volume reclaim policy. Here I have set recycle. There are currently three types of reclaim policy. The first one is retain. After deleting the PVC, PV still exists and volume consider release. But it is not yet available for another claim because the previous claimant data remain on the volume. An administrator can manually reclaim the volume. The second one is delete. Deletion remove both the persistent volume object from the Kubernetes as well as the associated storage asset in the external infrastructure. The last one is recycle. The recycle reclaim policy is deprecated. Instead of this, the recommended approach is to use dynamic provisioning if you want to use this option. Currently, only NFS and hostPath support recycling. AWS, EBS, GCE, PD, Azure Disk, Cinder Volume support deletion. Next is capacity. Here we define how much storage capacity this volume can consume. So here we define 3 gig. Next is volume mode. Here I select file system. In this we have only two options available inside volume mode. One is file system, the other one is block system. Volume mode is an optional API parameters. Kubernetes supports two volume mode, as I said, file system and block. File system is the default mode used when volume mode parameter is not defined. If we are not defining this information, then by default it will select file system. But to explain this topic, I have already mentioned this thing for you. File system is mounted into pods into a directory. In block device, if the device is empty, Kubernetes create a file system on the device before mounting it for the first time. No need to further explanation, it is very clear. You can set the value of volume mode to block to use volume as a raw block device. So next is NFS. Type of persistent volume. Persistent volume types are implemented as a plugin. Kubernetes support following plugins: Chef, CSI, Container Storage Interface, FC, Fiber Channel, hostPath, iSCSI, Local, NFS, RBD. In this example, we create type NFS PV and the helper program has been mount NFS is required to support the mounting of NFS file system. As of now, I don't have any Kubernetes or AWS bucket I purchased. I created a new VM and on the top of that I install the NFS server and export that directory. That is my fourth VM. In a Kubernetes cluster I have 3 VMs, so fourth VM I added as a NFS server. I will show you in a couple of minutes. This option I have selected here, NFS, and before going to there, so inside this NFS we have path. So I created one directory inside home directory NFS share data, and this is my NFS server IP address. So this directory will be mounted in my Kubernetes cluster. I will show you. The next one is storage class name. A class, a PV can have a class which is specified by setting the storage class name attribute to the name of the storage class. In simple term, we can say that in storage, we are just giving a name of that storage. This is a storage class name. A PV of a particular class can only be bound to PVC requesting that class. PV of a particular class can be bound to PV. In this example, it is in this line, it is simple says that PV can be bound if we specify some storage class here. A PV with no storage class name has no class and can be bound to PVC that requests no particular class. So by default, sometimes we create a default storage, and if you are not providing any storage class name, that PV will mount to default storage class. In past, the annotation volume beta Kubernetes storage class was used instead of storage class name. So storage class name is a new attribute. This annotation is still working. However, it will become fully deprecated in the future Kubernetes release. The storage class will be deprecated. So instead of using the storage hyphen class, you should use storage class name. And the last one is mount option. How we can mount this NFS server. So hard and NFS version 4.1 I have just mentioned here. That's it. Nothing more than that. This is my PV YAML file. I just explained most of all the options. And this is my persistent volume claim. In this, the kind is persistent volume claim. And the name of this persistent volume claim is task PV claim. And storage class name is NFS. As I said that we have to define some storage class name. This NFS is having the same name, so it will bind with this persistent volume. This claim will claim this PV. You can think about that. And storage is 3 gig, and here I have mentioned 3 gig here. And the last one is pod YAML file. In this YAML file, the very first thing is the kind is pod, and the name of this pod is my pod. Inside this specs, we have a volume section as I already described in EmptyDir and hostPath. And the name of this volume is myPD. And you can see here that inside this container we have myPD. I will cover. And persistent volume claim. So as you can see here that this persistent volume claim, I have mentioned the same name here, task PV claim. So it means that this port will trigger this persistent volume claim as the name is same, task PV claim. And inside this container we have volume mount, and this name is same as you can see here that inside this container will look for this volume and mount this persistent volume into www.html directory here, the mount path. And further, persistent volume claim will send the request to persistent volume, and inside this persistent volume here we define NFS server path, home NFS share. So it will mount to in this directory here. So I hope this 3D animation help you to understand that how it work actually. I just tried my best. These are the 3 different YAML files that we need to create here. Persistent volume claim. And this is my storage class name. Storage class name is NFS. What similarity in between these 3 YAML files? This is what I am going to explain here. Between persistent volume and persistent volume claim, we have storage class name is same. And between persistent volume claim and pod, what we have same? The persistent volume claim name. And inside this pod we have volume and volume mount name is same. So from container here it goes to here. This is the data will go here. So as you can see here that this name is same, this name is same, and from it reach here the chain, and after this chain it will trigger persistent volume claim, and from persistent volume claim it will look for storage class NFS. This storage class NFS is mentioned in this persistent volume. So as you can see here that this persistent volume has storage class name, and inside this we have defined the NFS server, and from this it will go to www mount the directory inside via www.html. This is my Kubernetes cluster. As I mentioned that a new VM installed, and the IP address is 192.168.1.34, and I installed the CentOS 9 operating system. On the top of that I installed the NFS server, export home NFS shared data directory. This directory I created and then exported here. So this is the IP address I mentioned here, and the path is this. To static volume. For static volume, you need to click on this static volume, and here we have couple of labs available. So let's proceed with the first one. Here I have already added three YAML files. One is for persistent volume, and the name of this persistent volume is NFSPV, and the reclaim policy is retain. It means that after deleting the PVC, I should have my data in my NFS server. And the storage is 3 gig. File system I'm using volume mode, and this is my NFS server IP address. If you have different IP, then you have to modify it, and obviously you have to update the path if you have different. In the persistent volume claim, the name of this persistent volume is task PV claim, and the storage class is NFS, same as it is in the PV. It should be same, and the capacity we are giving is 3 gig, and the access mode is read write many. Inside this deployment YAML file, you will observe the persistent volume claim. Claim name is task PV claim that we have mentioned, task PV claim in the persistent volume claim. And the name of this volume that we have defined here is static NFS volume, and the same name we have defined inside this volume mount. Name is the same. And inside this container, we will observe where www.html directory. It should be exported from the NFS server. Nothing more in this YAML file. We have already covered all these things in our theory part. Let me log in into my master server here. Right click and enter. Clear the screen. In order to create all these three YAML files, I just need to apply only one file because I binded all three YAML file in a single one. As you can observe, NFS PV is created, task PV claim is created, and one static deployment is also created. These are the names that I have defined in the YAML file. kubectl get PV and PVC. I should see here the bound status is bound. If I explore this PV, the name of the PV is NFS PV. The capacity is 3 gig, and the access mode is read write many, and the reclaim policy is retain. It means that after deleting the PV and PVC, I should have my files saved on my NFS server. The status is bound, and who claim? So this PVC claimed this PV, and the storage class name is NFS. Same thing you will observe in the persistent volume claim. The name of this persistent volume claim is task PV claim. Status is bound. Volume NFS PV, that is this. Capacity is 3 gig. Read write many. Storage class is NFS, and here it is NFS. While doing the troubleshooting, these options can be helpful. Let's go with kubectl get pod. My pod is running. After this, log in into the pod and check the volume mount path. So I'm just copy from till here. Press tab, it is automatically created here, and then --bin bash. If I execute df space -h command, I should see where www.html directory, and it is mounted from the NFS server, and this is the path. And if I copy here, if I go to my storage server, NFS server, as you can see here, the prompt is different. And if I ls space ltr, there is no file. So inside this where www.html directory, there should also be not a single file you will observe here. So let me do ls space ltr. Yes, there is no file available. Create a file inside the pod. So I'm just doing here echo first line. I'm just going to create a new file, static file1. First line updated from the static NFS pod. Here, let me clear the screen here. I can see this file. Yes. First line updated from static NFS pod. And the same thing I should observe here. Static file. It means that whenever we are creating anything on this pod, any file or directory, it is creating inside the NFS server. As you can see here that my NFS IP address is different, 1.34. Okay. Check the NFS server for the particular location. I did already. Update the file on NFS server. It means that if I update directly on the NFS server, will it be reflect on the pod? Let's see. Now I'm inside this pod here. Second line updated from the NFS. If you update any file from the NFS server or pod, it will be reflected to all the location. Check the file. Yes, I did. Now delete the pod and new pod will be created thanks to deployment and verify this file is still exist or not. So I'm just going to use this option. Let me exit from this container and then execute this command. Now if I use pod, I should see a new pod will be created thanks to replica set, and this replica set is a part of deployment. Now log in again, kubectl execute -it and this name hyphen bin bash. I should see this file where www.html. Yes, the file is there. I can see the content. It means that if pod is deleted, I do not need to worry about my storage files. Now I'm going to delete the deployment, which will delete the pod. After that, delete the PVC. Check if our file is still exists on the NFS server or not. For this, again, I need to exit from this pod. kubectl get deployment. Let me delete deployment. It is deleted. Let's verify. Yes, nothing is there. And if I execute kubectl get PV and PVC, so here I'm going to delete my PVC, not PV. Now I can see my only PV is available here. Let's go to storage server and check if this file is exist or not. Yes, it exists and I can read this file. Now delete the PV and check if this file is still there. Let me delete this PV. No resources available here. Let's go to our NFS server and check if I can see this file. Yes, I can see this file. So it means from the above level, it is clear that if we set the reclaim policy value to retain, our file will always available. If we deploy same PVC and deployment, we will observe same file in the pod. So let me copy this file again and log in inside this pod -bin bash. If we use the same server, NFS server and same directory, we can see the files and content. Now clear the lab here from the master server. So let me exit from this pod and execute this command here. Clear the lab from the NFS server. I need to copy here. Nothing is here. This is the benefit of reclaim policy retain value. Let's do with this reclaim policy recycle. Same thing we will do here. I have mentioned recycle. Data will be deleted. So when we delete the PVC, our data will be removed. So let's do it here. Let's proceed for the lab here. I don't have any file here inside this directory. Now I should have one new file. All the values are same, just for information. If it's created bound, yes, it is bound. And now the reclaim policy is recycle. It means if it will do rm space rf on that directory. As per our theory, let's go with this. Login into the pod. This is the command. I don't need to copy these value now. So what I do here, I'm just using kubectl execute -it, and inside this dollar, I'm using kubectl get pod and grab static pod awk $1. So it will print me this value only, and then log in inside this pod. Now create one file and check if this NFS is there or not. So I need to go to this directory ls space ltr. I should not see a single file here. Yes, it is the case. Let me create one new file, echo first line updated from static port nfs reclaim recycle file. Yes, it is there. Let's go to storage server and then check this file. Yes, this file is created. First line updated from the static. It's time to delete the deployment. We already know that if we delete the pod, it will create it by the deployment and our files are there, right? So I'm just going to delete directly deployment. Exit from here, clear the screen, and deployment, static deployment, I have just deleted here. Let's check if this file is there. Yes, this file is there. Very good. Now delete the PVC. So it is only deleting PVC and then get PVC. Now I have only NFS PV. What our lab says, observe the column status of PV. It should be release state. Okay, now the status is released. If I create a new PVC, it will be bound here. This is the minimum. But this time I'm not able to see or read this file on the NFS server. It means that if we select the reclaim policy to recycle in PV config, it will delete the data from the external storage server if we delete the PVC. Okay, if this is the case, so I should not see this file here. Yes, this file is removed. It means that if we want to delete all the files, we can use reclaim policy to recycle. Clear the lab, delete PV and NFS. Delete this, and I should not see anything here, right? And rm space minus f reclaim policy deleted. The third one is delete. If we set the reclaim policy to delete, what it will do? It's a question mark. It will not delete anything from the NFS server if we delete the PV and PVC. Why? Because in NFS, provisioner is not able to match this delete option is available with the NFS. As I said in my theory part that you need to check which option is available for different provisioner. For NFS, this delete option will not work. So it means that if I use this delete option, it will treat it as retain. So let me show you here that here I created, I can see the reclaim policy is delete. The pod is running here. If I go inside this pod and create one new file and reclaim policy delete, I can see the updated file. It's time to delete the deployment. I just deleted the deployment and get PVC. Both are there, PV and PVC. I can see from the NFS server. Yes, I can see this file here. Now delete the PVC. When I'm going to delete this PVC, observe the status of PV. It should be in field status. Yes, it is in the field status. For the volume plugin that support the delete reclaim policy deletion, remove both the persistent volume object from the Kubernetes as well as the associated storage asset in the external infrastructure such as AWS, EBS, GCE, this one. So NFS is not available here. So if we use these PV for the external infrastructure, if we use delete option, it will delete all the content from the server, storage server. But here we are using NFS, so it is not deleting anything. Let me show you here. kubectl get PV and PVC. I can see only PV, but still I can see the NFS server here. So this delete option is not working with NFS. So I'm not going to perform this lab. Maybe if you want, you can perform this lab at your side.